Okay, we've been working on differentiation, and here is the first of the optimization problems that we're going to tackle. So you need to turn to this booklet that you've got, and if you move towards the back of the booklet, you'll find an example. This example here, and it's a optimization problem, sometimes called maxima and minima problems. So here's the example. We've got a pocket mirror, which is basically a rectangle. We're told its breadth is x, we're told its perimeter is 16, and we've defined an expression for the area of the mirror, and then we need to calculate the dimensions that give us the maximum area. So it's a fairly typical, straightforward question. For these kind of questions, the first things you should always do at least, are draw some diagrams. It makes it a lot easier to focus in on what it is you need to find. And then you need to remember some basic formulas. So typically it could be to do with area of a rectangle, volume of a cuboid, etc. It could be to do with triangles, just basic shapes that you should know some of the formula for. So the first thing we're going to do is start off by drawing a diagram, as I said. So here we go. I've got a rectangle here. We know its dimension is x. So we've got this dimension here is x. We don't know what this dimension is, so we'll just call it h, and we know the perimeter is 16. And then the two basic formula that we're interested in is the formula for the area of a rectangle and the formula for the perimeter of a rectangle. So we use our basic maths, and the formula we are interested in is the formula. Initially, we're trying to find the formula for the area. So the basic formula is area is length times breadth. So in this case, we've got x times h. The problem is the question is asking us to find a formula for the area in terms of x, and currently we've got x and h. So we need to look at the other information we've been given, and the other information we've been given is to do with the perimeter. We know that the perimeter is going to be 2 times x plus 2 times h, and it's just a case of rearranging this formula because we know the perimeter is 16, it told us that. We need to rearrange this formula to figure out what h is. So when we rearrange it, we get h equals 8 minus x. We then take the letter h, and we're essentially replacing it with 8. Minus x, which gives us our expression for the area now in terms of x, which is x times 8 minus x, which of course we can multiply out the brackets to get 8x minus x squared. So that's the first part of the question done. We have found an expression for the area of the glass in terms of x. The next part of the question says find the dimensions of a rectangle that give the maximum area. So in order to find information about maximum, we need to differentiate it. So when we differentiate 8x minus x squared, we get 8 minus 2x. We know that for any stationary values, which a maximum of course is going to be, we know that the derivative needs to be equal to 0, which gives us 8 minus 2x equals 0, and we can solve that to get x equals 4. At that point we need to make sure that it's a maximum it's given us, so we need to do a nature table. So for our nature table, we're putting in the value of 4, and we're looking either side of it to find out what the derivative is. So to the left of 4, the obvious number to put in is 3, so we get 8 minus 6, which of course is positive. So we know that's positive. We know, of course, when it's equal to 4, it's 0. Then we put in something to the right of 4, slightly bigger, so 5 is the obvious choice. That'll give us 8 minus 10, which is a negative number. So when we look at that, we get that, and we can see that it is in fact a maximum value. Hence, we've got a maximum value when x equals 4. The question, of course, asks us to find the dimensions of the rectangle. So we know the length is x, which is 4 centimetres, and the breadth is 8 minus x, which gives us 8 minus 4, which gives us 4 centimetres as well. And just to finish off the question, actually asks us to figure out the maximum area. So the maximum area is just 4 times 4, which is 16 square centimetres. So there are quite a few problems for you to try, directed to in the booklet. Have a go at them, and I will post another example shortly.